So the question is asking us to find the nth derivative of this function. What they are trying to say is we find the formula such that when we just say what is the first derivative, you just get one and put in that formula and find the and supposed to give you the derivative. When you are asked to find what is the third derivative, you just get the 3, you put in the formula and find that derivative. So how can we do that? The first thing that I would advise for this question is we rewrite it in that we're going to have y is equals to, since everything is at the denominator and it's 1 over that, we're going to have it as 1 minus 2x the power negative 1. Since it's in this form, we're going to use the chain rule to differentiate. So for this equation, you tend to differentiate it 3, 4 or 5 times. If you can't see the pattern, you even go to 16th time. But if you can easily see the pattern, well and good, you can just go direct and start picking the necessary parts of the formula. So for the first part, we find the first derivative. Our first derivative here is going to be, we drop the 1 here, it's negative 1 here, the power negative 1 multiplied by the 1 this side. When you drop it, you are going to have negative 1 minus 2x the power. You subtract 1 here, you get negative 2. And since it's a function in a function, we are going to also differentiate the inside the function, meaning that you say multiplied by the derivative of the inside, we get negative 2. So you notice that this negative and this negative can cancel out to be a positive. But before that, let's check the next derivative if it will be the case also. So the second derivative is going to be equal to, we have a negative here, negative 2 multiplied by negative 1, right? So we have a negative 1 multiplied by negative 2. Then we have 1 minus, okay, we have 1 minus 2x to the power. When you subtract a 1 here, we're going to have a negative 3. So negative 3 here multiplied by this negative 2 will come, multiplied by the derivative of the inside is still negative 2. So another negative 2 will come. Meaning that when you check for the signs, we have a negative here multiplied by this negative, it's positive. Negative here and this negative, it's also positive. Meaning throughout we are going to be producing values that have positive functions. So in this case, we can say we find our third derivative, of which is going to be this negative 3, which is the power, multiplied by everything here. So when you multiply, you are going to get negative 1 multiplied by negative 2 multiplied by negative 3. Then 1 minus 2x the power negative, since it's 3 here, we subtract 1, you get negative 4. To this one, we're going to multiply it by the differentiation. Here we already have 2 of them, so it will be 2 multiplied by negative 2 multiplied by another negative 2 when you differentiate the inside here. Okay, so another negative 2, we are going to have it here, of which some of us can already see the pattern that is being formed. For those who can't see it, you go to the fourth and fifth derivative and see what is happening. So going to the fourth derivative, we are going to have negative 1 multiplied by negative 2 multiplied by negative 3 multiplied by negative 4. Then we write the way the equation is, which is 1 minus 2x the power negative 5. Then multiplied by negative 2 multiplied by negative 2 multiplied by negative 2, and the last negative 2. So from here we can start picking up parts that will make up our formula. So y to the power n, or the nth derivative, is going to be equal to, first thing is all these negative signs we are seeing are going to be positive when you simplify. So no need to consider the sign changes because it will always be positive. The second part is how the coefficients are changing. We have a 1, then you introduce a 2, you have a 1, 2, 3, you have a 1, 2, 3, and 4. How are they changing? It's more like the first derivative is 1. The second derivative you multiply by 2. The third derivative you multiply by 3. Fourth derivative multiply by 4. And this pattern is associated with the n factorial. When you say 1 factorial, it's 1. Say 2 factorial, it's 2 times 1. 3 factorial, it's 3 times 2 times 1. That's how it's also following. So instead of us writing all these numbers here, we can just simplify by saying it's n factorial. Okay, that's a pattern. Whenever you see that numbers are moving 1, 2, 3, 4 like that, but they are multiplying, use n factorial. Then the next part is okay, we write the way the equation is 1 minus 2x. Okay, now we go to the power. For the power, we notice that for the second for the first derivative it's a negative 2, the third derivative negative 3, fourth derivative negative 4, negative 5 for the fifth derivative, meaning that there's only a difference of 1. So since they are changing like that, 2, 3, 4, 5 like that, and to make sure that they follow the order, we are starting from a negative 2 here and not negative 1. So we are going to say it's n plus 1. Okay, n plus 1, or you can use arithmetic progression here. It's going to give you n plus 1. Just to try it, we have a 2, 3, 4, 5 here, meaning that when you use arithmetic progression to find the formula, we have Tn, which will be equal to a plus n minus c. Okay, we have n minus 1 the power multiplied by d. This a is our first term, so we're going to say our first term is 2 here. So plus our n minus 1. Then the difference between these numbers here, the difference here it's 1, the difference here it's 1, so throughout it's just 1. So we're going to have a 1 here. Then here when you simplify, you get 2 plus n minus 1, meaning that our n, our final answer is going to be n plus 1. So this is how the powers are changing, n plus 1, meaning that if it's the first derivative, you put 1 here, then 1 plus 1 is going to be a 2. It's the 2 that we are seeing on the first derivative. So the power for the power change, it's n plus 1. But you notice that they are all negatives. Okay, they are all negatives, and when making the formula we only got positive values. So to handle that negative part, you can multiply everything by a negative value. If you use the negative values here when finding the formula, no need of including a negative, it's going to come out on its own. Alright, from there we move to this part for 2. So we say multiply by. You notice that for the first derivative here, it was just a 2. The second derivative, it's a 2 times 2. Third derivative, it's a 2 times 2 times 2, meaning more like it's first derivative we say 2 power 1. Second derivative, it's 2 power 2. Third derivative, 2 power 3. So it's following the number of derivatives that we are taking. So in other words, this is more like the same as 2 the power n. So that when it's 1, it will also be 1. When it's 2, it will also be 2. 3, 3, like that, moving. After that, we can say our final equation is just 2 power n, and n factorial 1 minus 2x, then everything to the power negative n plus 1. This is our formula here, the nth derivative, meaning that if you are asked to say find the ninth derivative, all you need to do is plug in the values. For example, the question was asking us to say find the ninth derivative. This ninth derivative will be equal to, we just put 9 where there is n. Okay, so the first part will be 2 power n, then multiplied by 9 factorial, then 1 minus 2x, 1 minus 2x, open, then 9. Here we have a 9 plus 1, so it will be 10. Simplifying this part, you get your ninth derivative. That's how it works. So when you find the nth derivative, just plugging in the number, then everything goes well.